Probabilities of draws with replacement. So once I draw it out, I'm going to put it back in, and the chance of drawing it again would be the same. So it says an urn contains 8 black and 9 green balls. 4 balls are randomly selected from the urn in succession with replacement. That is, after each draw, the selected ball will return to the urn. What is the probability that all 4 balls drawn from the urn are green? What we're going to do is the probability of each one separately and then multiply those probabilities together. So, I'm going to draw 4 balls from the urn. I want the probability that all of them are green. If I'm going to do my first draw, I'm going to have 9 green balls out of 17 of them all together. So the chance of getting a green one is 9 out of 17. Since I'm going to replace my ball once I draw it out, my probability of getting a green one on the second one is still going to be the same thing. 9 out of 17. Again, I'm going to replace my ball on the third one, so to get the green one would be the same thing, and the last one would be the same thing. So basically, I'm going to just have 9/17 to the 4th power because all 4 of them would give us the same probability. They are going to round these off to 3 decimal places. So you can either do 9/17 times 9/17 times 9/17 times 9/17, or take 9/17 to the 4th power. Nope, I don't think it's 1 point something.
Oh.
If you are doing your exponent, you may need the parentheses around your fraction.
.08.
We're going to 3 decimal places. So we're going to have point
079.
There we go. 0.079 is where that would round off to 3 decimal places. Okay. Number 8. We have a fair die that's rolled 5 times. What is the probability of having no 1s and no 2s? So what's the probability of not having a 1 or a 2 on my dice?
2 are 1/3. 2 out of 6.
That's having a 1 or a 2. We want to have not having a 1 or a 2.
4 out of 6.
4 out of 6. You could reduce that down if you wanted to. We're going to roll the dice 5 times. So again, since I'm going to get the same chance all 5 times, I can just take it to the 5th power. Or 4 6 times 4 6 times 4 6. You want to reduce it down to 2/3, it'd be the same thing. And again, we're rounding it off to 3 decimal places.
0.132.
0.132, okay. A fair dice is rolled 5 times again. What is the probability that a 6 is obtained on at least one of the that a 6 is obtained on at least one of the rolls? So on this one, because it would be hard to figure out that at least one of the rolls, what we want to do is figure out if it's not going to be a 6, and then we're going to take 1 minus that value. 1 would be 100% chance, and so if we do 1 minus, so if I'm not going to get a 6 on my roll, I have a 5/6 chance of not getting a 6, right? So I would have 5 6 to the 5th power. I'm going to do 1 minus that answer since I actually want to get a 6 on one of my rolls. .598, yep, is what you should come up with. So on this one where they say at least one of the rolls, what you want to do really is figure out if it's not on any of the rolls, because it's be easier to do. And then you take 1 minus that answer. All right, the next ones we are now not going to replace, so our values won't be exactly the same every time.